Let's take a look at the design of the experiment we just analyzed with AI. You might have noticed that the combinations of pH and temperature were done in a basically random order. Why is that? Well, let's think about what could happen if we did them in what seems like a more natural order. So like pH of 6.5 at all these temperatures, 35, 37, 39. pH of 7.5, 35, 37, 39 temperature. pH of 8.5, 37, 35, 37, 39 temperature. Why shouldn't we do it that way? So pause the video while you think about why we shouldn't do it that way. All right, welcome back from pausing. So it's quite possible that something else that we aren't even thinking about or measuring is going on as time goes on that would affect the yields of our experiment. Maybe the chemicals we prepared at the start of the day are absorbing oxygen from the air and kind of changing. Maybe the machine we use to read out the yields or something is warming up, and that can affect the readings. Maybe you, the experimenter, are getting better at doing things, or maybe you're getting worse because of fatigue. Maybe your measured yields are increasing as the day goes on, but we have no idea whether it's increasing due to the higher pH values we're trying later in the day, or if it's increasing due to any of those other factors I just mentioned. And we wouldn't even know, even if we had taken data on the temperature of the machine and your fatigue and your learning curve and the oxygen absorbed. So we say that pH, here pH was increasing through the day, and any of those other factors, those are confounded variables. And it means basically you can't tell which of them caused whatever output you saw. A related word is lurking variables. That's confounded, but we have no data on it. So the pH is definitely confounded with time. Even the temperature of the reaction is confounded with time because all the higher temperatures always got run later than the lower temperatures within any one pH block. So it's really important to not set up your experiment to end up with confounding variables. So we got to spend time planning how you'll analyze your data before you even collect it, include what graphs you'll make and what numerical procedures you'll use. Doing that can reduce the chances of ending up finding out later that you should have collected data on something you forgot or done things in a different sequence. There's a saying which is harsher than I would usually say it, but it makes the point. You can't fix by analysis what you bungled by design. And here's the citation for the book that came from or article. Uh, Even before you spend time planning your experiment, you can use AI to create artificial data in the same format that you expect to store your real data in. Then create your analysis procedures on that artificial data before you finalize your data collection system and actually start taking data. That's also a good way to avoid the temptation to say, "Oh, I'll analyze it this way and this way and this way and this way until I find the thing I was trying to prove anyway." Really, you're supposed to set your analysis procedures ahead of time and even make them public. That's called pre-registering a trial. It's becoming more and more required by funding agencies. So let's take a look next at designing a study with generative AI.